Okay, so I'm about to show you what I did for my chapter 7 homework. So we'll just go all the way down and just restart. So the first thing that I did was conduct a simple linear regression between the number of pubs and mortality rates. So I did this. I'm going to run it here. So essentially it asks us if the number of pubs is a significant predictor of mortality rates. Yes to that question, and kind of like going in a little bit on what we're seeing here. So multiple r squared, knowing what we know about r squared, it tells us how much a variable accounts for the relationship or overall. So the number of pubs accounts for 65, and I rounded with that number, 65% in the relationship. The remaining is unaccounted for. And then looking at our beta values, we know that our beta values essentially kind of, well, specific ones tell us changes how the predictor outcome is reflected in the beta values. In that when there's changes in the predictor variable, then there's changes in the outcome variable. So So knowing what we know, as the number of pubs go up, mortality rates go up by 14.339, and this itself is significant. With t value, and the bigger the t value, the bigger contribution. This is a significant value right here. So it can be concluded that the number of pubs has a significant contribution on mortality rates. So in essence, in a long-winded answer, yes, pubs is a significant predictor for mortality. So now we're going to move on to task 2. So the first thing that I did, I made a model just like Andy Fields did, and I just used age and salary. Made another one that accounts for, really quickly. I made another model with adding beauty in years. And this is our summary for our salary model 1. And then for salary model 2, we ran that. So really quickly, our question asks, how much does the overall model predict for the variance in salary? Looking at all of our variables right here, our overall model predicts essentially like 18.4% for our what else did we want? Right. So it predicts 18.4% for the variance in salary overall. Well, some of the variables, but specifically, yeah, no, I'm right. Okay, never mind. Ignore me. So now the second question was asked, how valid is the regression model? In other words, can we trust it? So we're given a hint. We have to check the assumptions. So really quickly, the ones that I just did that were straight up from the book. To check for independent areas, I used the Durbin-Watson test. So we're going to run that. And Andy Fields essentially gives us a rule of thumb that if it is around 2, it's okay, it's fine. And looking at our p-value, we're essentially given 0.67. So we already know that this isn't a significant statistic, being that it's non-significant, which sucks because this is kind of close to 2, maybe a little bit over, but barely. So as far as independent errors, it's not significant, so we can't necessarily assume it. Actually, no, we can't assume it at all. Now we check for multicollinearity. So we have to do the BIF, and it indicates whether a predictor has a strong linear relationship with other predictors. So we're going to run that. And I'm also going to run tolerance and average of the BIF. Okay. So Andy Fields mentions that if there is a variable with the highest BIF value for a certain variable, if that is greater than 10, there's a problem that we have to be concerned about. Looking at it right now, age is the bigger BIF value, so we got to be worried. Tolerance. So Andy Fields mentions that our tolerance, if it is below 0.1, is a serious problem. If it's below 0.2, it's kind of potentially concerning, but we want it to be higher. So looking at our VIF values, age in years are a lot lower than 0.1. So this is concern for us. However, well, not really, however, because this is still kind of bad. If the average VIF is greater than 1, then the regression may be biased. Our average is 8.65432. So this isn't a good sign. So we cannot assume multicollinearity. Now, looking for homoscedasticity and linearity, we're gonna plot some points. Okay, we're gonna plot this. No, that's not what I wanted. Gonna run this. Okay, so why is it giving me that? Oh, wait, I know why. I know why. Alright, so I'm not really worried about that because it's all here. Let's see. One more over. Okay. So essentially we're looking at this plot and we see our dots all over the place. So Andy Fields mentions that for an indication of heteroscedasticity, we have a cone-shaped type of form going on. So, but we don't see that here. So we have homoscedasticity. Now linearity, essentially if we see a curve or anything like that, then there's no linearity at all. So essentially we're seeing kind of like a curve thing going on in our plot. So we can't assume linearity. Bummer. So now we can also do a histogram. Well, I'm just gonna, instead of just running that, I'm just gonna do this because I don't want to go through all that again. Got like 4 minutes left or something like that. Anyways, so looking at our histogram, we can see that it's skewed. So we don't really, looking at it, and it just doesn't look like a normal distribution. So essentially our model violates some assumptions, which really sucks. But nonetheless, I'm not going to cry about it. We're going to move on. So now, and I'm just going to scroll up because apparently it looked like it did everything. Yeah, it did. Sweet. So I don't have to run that. Alright, so the next thing we're asked is to run a hierarchical regression. So the first thing that I did was make a model with sibling aggression and parenting styles. So we're going to move up here. This is what this is. And then I also made a another model including all the other variables as stated. So this is all this. Now it's asking us, going down here, we have to get the standardized parameters, and then we have to compare the R-squares from both models using an ANOVA. So I ran the ln betas, and then, well, for both of them actually. So essentially, when we ran them, we're looking at it essentially tells us the importance of our variables, and it's essentially their standardized beta values, so they're easier to interpret too. So they tell us the number of standard deviations by which the outcome will change as a result of one standard deviation change in the predictor. So once again, importance. So yeah, it's great. Now it's also asking us, compare R squared for the ANOVAs. Sweet. Okay, so R squared. Where are you, R squared? Alright. So basically our model has improved thanks to adding in all these other variables, which is great. So another thing that was asked is, what's the point of conducting a hierarchical regression rather than just throwing in all the variables? The point of hierarchical regressions is that it's essentially, you don't, basically the computer chooses, but you should pick predictors that are based on past work. When you just throw them in there, it's not only is it sloppy, it's just it throws everything off, and you may not get something that you want to get. So yeah, I mean that's pretty much it. Just don't do it. So that's that. So based on the final model, which variables are predictors of aggression? So basically, parenting styles for sure is a predictor of aggression. And what else did I see something too? Well, just really given from what we already know about parenting styles. Yes, parenting styles is a predictor of aggression. Yep, and that's it.